In this video, I'm going to talk about multiplying and dividing integers. Multiplying and dividing integers don't require as much thinking because there are rules that go along with multiplying and dividing integers that make it very easy to follow along. There are only two rules you need to remember for multiplying and dividing integers. If your numbers have the same sign, the answer is going to be positive. Lucky for you, you already know how to multiply numbers, so this is just taking your multiplication that you already know, and then you're just adding a sign to it. If they have a different sign, then you're going to have a negative answer. So let's look at some of those examples. So for instance, 5 times 3. I already know that 5 times 3 is 15. These have the same sign, because they are both positive. That's like an invisible plus sign, but they're both positive, so therefore my answer is also positive. Negative 5 times 3. Once again, just looking at the numbers, it's 15. If I look at the sign, I have a negative and a positive. That's a different sign, so it's going to be a negative answer, negative 15. 5 times 3, once again, just looking at the numbers, is 15. Then I have a positive and a negative. Those are different, so it's a negative answer because they're different signs. Here I have negative 5 times negative 3. Those are the same sign. A negative and a negative, they're the same sign. So it's going to be a positive answer. I often find it helpful, if you're doing a lot of multiplying and dividing problems, or even if you're not, to just sort of think about the sign first. Get that out of the way, and then you can you can often use a calculator for the actual math if you got stuck for some reason and didn't have it memorized. Or if they were just larger numbers, then you could use a calculator for the numbers, but the sign is already taken care of because you've already thought through that. So I think these are positive, both positive. So because they're the same sign, it's going to be a positive answer. These are different. I have a negative and a positive, so it's going to be a negative answer. These are different. It's a positive and a negative, so I'm going to have a negative answer. These are the same. So I'm going to have a negative and a negative. That means that I have a positive answer. Now, I made all of these the same. 20 divided by 5 is 4, and it's the same digit all the way down. It's just the sign that changes. So one thing that can trip people up a little bit is if you have a string of multiplication and division signs. So you have a series of numbers that you're trying to figure out, okay? So that actually does, matter a good bit. You want to make sure that you are going to change this one. Okay. So you do want to make sure that you're following order of operations by going left to right. So you're following order of operations going left to right, and that means that you're looking at each set. Sorry guys. That was a very quiet sneeze. So I'm just going to go left to right with my multiplication and division and do each step and part. So negative 5 times negative 6 would be a positive 30 because they are the same sign, positive 30, divided by 2. This is still a positive 2. These are both positive now, so my answer is going to be positive 15. Okay, then I can do left to right with this one as well. So 2 times 4 is 8. Those are both positive, so my answer is positive. 8 times negative 5. Those are different, so my answer is going to be negative. 8 times negative 5, negative 40. So if you have a series of multiplication, division problems, they're part of an order of operations, you just do them left to right. Unless, of course, you are looking at parentheses first, okay? So you still would follow order of operations. But if you have a string of numbers all kind of with one another, then you just go left to right, multiplication and division. If I had addition and subtraction mixed in here, remember that I need to do multiplication and division first, and then do my addition and subtraction afterwards. Okay, so there still might be a couple of lingering questions as to why does this rule work. So we did some practice in class discovering how these rules kind of come to be. And so I just want to remind you of those, particularly with the negative times the negative, or the negative divided by a negative equals a positive, because that can sometimes throw people off. And this isn't like a trick, there's a way that we can think about it. And so I can use counters for this as really the easiest way, and I'm just going to do 2 examples of how 2 negatives can make a positive. So here I have negative 16 divided by negative 4. So why does this end up being a positive 4? If I think about division as like how many groups can go into something else, then really what this problem is asking me is it's saying how many times does negative 4 fit into negative 16? 4 times. There are 4 groups of negative 4. So I can't have like negative groups. That doesn't make sense. So this is saying that I have 4 groups of negative 4. That's also likewise if these were all positives. If I did negative 16 divided by 4, then it would be like how many groups of 4 can I get out of negative 16? Like how, if I have 4 groups, I'm taking negative 16, I'm dividing it into 4 groups. Once again, I can't really have negative groups. So if I'm dividing it into those 4 groups, how many are going to be in each group? Negative 4. There's negative 4 in each group, not positive 4 in each group. Because I have 4 groups, and how many are in each group? Those negative 4 counters. Okay, same thing, thinking about how multiplication works. So negative 5 times a negative 2. If I'm multiplying integers with counters, the way that I can start with that is by laying out a whole bunch of 0 pairs. So that's what I have here. I have a whole bunch of 0 pairs. I have 12 0 pairs laid out. And now what I'm thinking about is my groups, because that's what multiplication is. Multiplication is like groups of things. We usually think of multiplication as repeated addition, which it is. So I'm like repeating the addition of lots of negative numbers, which ends up being more negative numbers. So these all of these operations flow together. Addition and subtraction are inverse operations of one another. Multiplication and division are inverse operations of each other. They're like reverse the same thing around. And then when I start mixing in these negative integers, when I have these negative numbers, all of those lines kind of blur together. These 4 operations are so closely knit. If you really understand how to add and how to subtract and how to multiply and how to divide, then you start to see how they all fit together. So here, if I have negative 5 times negative 2, what I'm doing is I'm taking away, in this case I kind of modeled it as taking away 2 groups of negative 5. Now how did I get that take away? Because this is a negative number. So I'm taking away, that's what that subtraction sign means again. I'm taking away two groups of -5. So I have -5 gone, and I have another -5 gone. And now that I've taken those away, what am I left with? +10. Because if I started with all of my 0 pairs, and I take those numbers away, I'm left with only the positive halves. So then I get +10 afterwards. And I could do more modeling of those problems as to how that comes to be, but the point is that these rules are based on understanding of math, on how numbers work together, and how these groups of numbers count, and how do I kind of count those numbers and group those numbers together. So that's something to keep in mind, that it's not just like, these rules are not just nonsense, these rules make mathematical sense. But all I have to do is remember 2 rules for multiplying and dividing. Same sign, positive answer, different sign, negative answer.